In this lesson on the converse of the Pythagorean theorem, we have two objectives, two goals here. First, we want to be able to investigate and use the converse of the Pythagorean theorem. Remember, to form the converse of an if-then statement, you just take the if and the then parts, the hypothesis and conclusion, and you swap positions with it. Is it true? Is it not true? That's what we're going to investigate. And the second objective, to be able to classify triangles using the Pythagorean formula. Well, the Pythagorean formula, c squared equaling a squared plus b squared, is supposed to only work for right triangles, right? Okay, yeah, that's where we're going with that second objective. All right, so here's the picture for the first one, being able to investigate and use the converse of the Pythagorean theorem. And you can see in this image, it looks like some sort of construction site. Maybe they're building a house or something. What's going on with this guy over here? I don't know. He's just, maybe he's the supervisor. He's having a good time. But the point of this is like what they're actually doing with this tape measure here. It's not just measuring like board lengths. No, has something to do with right triangles, has something to do with right angles. That's what we're going to investigate here on our first investigation. Prior to that, let me ask a couple of questions. The first one is to state the Pythagorean theorem in if-then form. Well, Pythagorean theorem is usually just thought of just the formula, the c squared is equal to a squared plus b squared, but there's more to it than that. What is the c, what's the a, and what's the b? So you have to first start off with a right triangle. So if triangle, let's say ABC, is a right triangle, where a and b are the lengths of the legs, and c is the length of the hypotenuse, then we can conclude c squared is equal to a squared plus b squared. You might be asking, like, why am I keep doing the c squared part first? Well, there is a very specific reason for that. Will also come out in the course of this lesson. All right, well, the second question here is what's the converse of that Pythagorean theorem? So I'm going to take the if and the then part and swap positions with it. And so I'm going to start with the formula first. If c squared is equal to a squared plus b squared, then a and b are the lengths of the legs, and c is the length of the hypotenuse of a right triangle. In other words, if the formula works, if numbers work in the formula, then it produces a right triangle. Is it true? That's what we're going to investigate here. So in order to do this investigation, what we're going to do is we're going to take some Pythagorean triples. You just pick one of these, like 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, or you can double them, triple them, whatever. Take half of them. You pick one of those Pythagorean triples, and we're going to construct ourselves a triangle with those and see if that thing makes a right triangle. To do that, we're going to use some string. Do you have some string laying around? Maybe an old kite you can rip it off of? Okay, so you're going to select a set of Pythagorean triples from that previous list, and you're going to mark off points A, B, and C, and D on that string to create those links from the Pythagorean triple. A, B, C, and D, wait, that's 4 points, right? Why do we want 4 points? Well, here, let me show you. So if I come back over here, and let me draw a little something for you. Let's say, for example, that we're going to do the 8, 15, 17 right triangle. Or maybe it's not a right triangle. I don't know. So we're going to take a length of string, let's say, and I'm going to put 4 dots on this thing. Let's say this A, B, and I'm going to probably use maybe some sort of marker or whatever so I can mark on this string. Yeah, see? And then over here, boop, here's point, whoops, hey, no, come on. This is point D. Okay, so I'm putting those points on the string such that the distance from the first one to the second one would be maybe 8 centimeters, 8 inches, whatever. You pick whatever unit that you want. And then the distance from B to C here would be 15 centimeters. And then finally the distance from, from C to D along this curve would be our last 17 centimeters, right? Okay, so far so good. We've got a string with some points marked on it, perhaps. right? And then what you're going to do is you're going to hold together the two endpoints, A and B, and stretch out the other ones. It says group members. You're probably doing this at home, right? So you're just going to have to do the best that you can with the 2 or 3 or 4 hands that you have. You want to carefully stretch out your rope to see if it forms a right triangle. So here, I'm going to go back over here and draw this out for you a little bit more. So let's say I have my string, and I'm going to put point A and D together. So maybe it looks sort of like this. And this point is both point A and point D. And then maybe I have over here point C, and then over here, whoops, nope, that would be a B, and this one be a C. And what your goal here to do, of course, is to stretch that guy out and then stretch this guy out to form a triangle and see if that triangle is in fact a right triangle, right? So you can measure that with a protractor. You can measure it with a corner of a piece of paper. You can see here, this is a rare photograph of the ancient Egyptian rope stretchers. Now, it's been colorized because they didn't have colored film back there, of course. But what you can see here over on the right-hand side, that we have a rope that has 1, 2, 3 equally spaced knots here. So this would be a 3 side. And then I have 1, 2, 3, 4. I have a 4 side. And here along this longest length, I have 1, 2, 3, 4, 5. It's like a 3, 4, 5 right triangle. This dude right here is holding together basically our point A and our point D. This one's at our point B, and this one's at our point C, and stretching it out. Does that thing, in fact, make a right triangle? So check out the next video where I do exactly this kind of thing, where I play the role of all 3 of these Egyptian rope stretchers.